Hello guys, welcome to another video. In this video we shall continue what we did in the last chapter, that is to find the limiting problems and derivatives of certain functions. So in the last video we learnt about how to find derivatives using the first principle, and we used the definition of limit. Just to revisit that, the derivative of a function f of x at x equals to a is given by f dashed of a equals to limit x tends to a f of x minus f of a whole divided by x minus a. So this is the definition of derivative of a function, and we can use it to our advantage to find the different derivatives. Now let us begin by solving different basic derivatives first, and then we can do the other ones later. So what are the derivatives that we are going to find? So trigonometrical identities are a great way to start off this list of chapters. So trigonometrical identities. Trigonometrical identities are a better way. So the derivatives which we are going to find is sin x and cos x. So let us begin by one of them. So sin x, let f of x equals to sin x, then the derivative of f of x is, so now we try to find the derivative using first principles, and it won't be that much hard because as we have already encountered this kind of problems before, we shall be accustomed by now to how to approach this kind of problems and how to solve the particular limit. So here, as you can see, the question asks us for f of x equals to sin of x. So the limiting definition would be limit x tends to a f of x minus f of a by x minus a, right? Another definition for the limit is what I am going to write now, is the definition what we are going to use while solving the problems. This is limit h tends to 0 f of a plus h minus f of a divided by h. This is a more standard definition of derivatives, and I think this is more useful than the other one, because the first one is usually the one where we convert from limit to derivatives, but this one actually helps us to find the derivatives in terms of the functions, elementary functions, directly from the limit. So using the value of f of x, we can write this as like this, right? Now we can use the formula using the formula for compound angles, that is, we can add and subtract angles inside sine, and we can also express them. So we can use the formula sine of a plus b equals to sin b cos a. So this is the formula, right? So using this formula, we can see that Sine of a plus h similarly would be now. When this is done, what we can do now is we can find the limit L. Actually, here we do not read the answer L. We already have a name for it. So f dash a is equals to limit h tends to 0 sine a cos h plus sine h cos a minus sine a divided by h, right? So what we can do is limit h tends to 0 sine h by h into cos a. So we can just take the second term here and we can take the first term common and we can write limit h tends to 0 1 minus cos of h by h, right? So this limit is 1, so it becomes cos of a, because we have learned about the limit x tends to 0 sin x by x in the previous videos. And the next one, sin a into, now we first use the formula for 1 minus cos theta is equals to 2 sin square 2 by theta. So using that formula it becomes minus 2 sin square h by 2 by h, and this limit goes to 0 because firstly sin h by, if it was sin h by 2 we could have found the answer, but since it is sin square h by 2 it goes to 0. So the answer is cos of a. So the derivative of sin of x at the point a is cos of a, right? Okay, we can do a similar calculation for cos of x as follows. So case 2 is, now the derivative would be defined as follows. Defined as follows: f dash a would be equals to limit x tends to a f of x minus f of a by x minus a, from which we can substitute h equals to x minus a to find the new definition which was more useful to us, which is like f of a plus h minus f of a divided by h, right? Now this would give us limit h tends to 0 cosine of a plus h minus cosine of a whole divided by h, right? So this means now we have to use the formula. Now trigonometry that cos of a plus h is equals to cos a cos h minus sin a sin h. Using this formula what we can do is as follows. Using this we have f dash a equals to limit h tends to 0 cos of a cos of h minus sin of a sin of h minus cos of a divided by h. So we can again distribute it as follows. Take cos of a common and we can write it as limit h tends to 0 cosine of h minus 1 by h minus sine of a common limit h tends to 0 sine of h by h. As we know from the previous example, this limit is 0, so this is 0 minus sine of a into 1 because this limit is 1 as we have done in previous examples. So the answer becomes minus sine of a. Okay, so that's the derivative we were trying to follow. A third example now could include the derivative of e to the power x. Derivative of e to the power x. So let f of x equals to e to the power x. Then let us evaluate the derivative at the point x itself. So what we are going to do is we are going to write it like this: h tends to 0, f of x plus h minus f of x divided by h. Okay, so this tells us limit h tends to 0 e to the power x plus h, because f of x is e to the power x. So f of x plus h would be e to the power x plus h minus e to the power x whole divided by h. We using the rule for indices, the law of indices, we can write this as e to the power x into e to the power h minus e to the power x whole divided by h. Now we can take e to the power x common as the limiting variable is h, so e to the power x is basically a constant here. We can write e to the power x into limit h tends to 0 e to the power h minus 1 divided by h. And as we know from previous experience, this limit is again equal to 1 as I have proved. So the answer is e to the power x. And as you can see, the derivative of e to the power x is e to the power x itself, which actually means that we can find the derivatives very clearly here, and this is the only function whose derivative is itself. Now once we are clear with the basic definitions of how to find derivatives, I can give you a list of basic functions and their derivatives. So let me write it down. List of common functions and their derivatives. So now I'm going to write down all the functions and their derivatives, and from the next video onwards we would be trying to implicate them and learn more about the chain rule. Okay, so the more we learn about the chain rule, the better. Okay, so derivative is usually written as d dx, where x is the derivative variable, and in bracket we write the function which we are differentiating. So this is the format that I am also going to use. So these are the three functions. Firstly, d dx of x to the power n is n into x to the power n minus 1. d dx of ln of x is 1 by x. d dx of a to the power x is a to the power x into log of a. Number 4. Is a to the power x. Number 5. Number 6. of tan x is basically equals to sec square x. Number 8, ddx of cot x would be equal to minus cosec square x. So I think these are some of the basic things, and there are other things as well that you need to know, but for the time being this should actually work pretty well. So let me write down some more rules. If fx and gx are two differentiable functions, then ddx of fx plus gx is equals to ddx of fx plus ddx of gx. So basically, if you are given to find out the derivative of the sum of two functions where both of the functions are differentiable, then the answer is basically the derivative of the first function added with the derivative of the second function. Similarly, if you are given something like this, where you have given the multiplication of two functions, then what you can do is try this. And finally, if you are given two functions in the form of division like this, then the answer is simply gx whole squared gx into f dashed x minus fx into g dashed x. And obviously here g of x not equals to 0. So these are the three rules also that you need to follow when solving for derivatives. And along with this, the most important theorem of all is the chain rule, which we shall do in the next lecture, where after that we can be free to evaluate any derivative we want by hand. It's a magical rule, so evaluating derivatives won't be a problem anymore once you learn and once you get a hang of that rule. But before that, you need to be very much confident about all these formulas. You need to memorize them by heart so that you can just tell them at your lips. So we'll see the next lecture and we will learn about the things I've mentioned. For then, please study them carefully, and also do not forget to check out the app link in the description for Breatter Maths app. It's a mathematical app where I post all the lectures and theory regarding this videos and video solutions as well. Thank you very much.